Module 27 Probability, Section 2 Addition Rule and Mathematical Expectation. You might have heard of Venn diagram. It is invention by John Venn. He was an English mathematician. So there are two kinds of set. The first kind of set where there is actually no overlap. Here you can see that on the left top left side you can see the red and green, there is absolutely no overlap. Here that is something, this kind of sets are known as mutually exclusive set. One example would be probability of picking heart is the red, while the green is probability of picking clubs. So as you see, there is not a single card in 52 deck standard card deck. There is no card has both the hearts and clubs. So the card is either hearts or the clubs or the claver, So now the other kinds of set is something called partially overlapping set. So one example would be the red is probability of picking an ace, while the green one is probability of picking hearts. So of course there is a partial overlap because there is a ace of hearts. There is one card that is both ace as well as the hearts. So that kind of set is known as partially overlapping set. So the partially overlapping sets are very important while calculating the additional rule as well as conditional rule. On the left side you can see this one is basically an intersection. The shaded area of a very small area is the intersection area. So intersection area is A and B. So that is the intersection area. So that is A and B is basically you have to multiply these two things together to get this A and B. The probabilities has to be multiplied. So on the right side of the top, the bottom panel shows the shaded area, the whole area including the overlap. So that kind of set of course is a partially overlapping. The whole thing is what you call the union of the two sets. A union B. So that is exactly is called A or B, or this is addition rule is that A or B is basically probability of A plus probability of B minus probability of the small overlapping area. So that is basically A and B is a small area. So that has to be subtracted as we will explain shortly. So this kind of logic or logical operator, and we just see what is and or. So these are something called logical operators are extensively used in the logic. So especially the logic by Boolean. So the George Boole is an English mathematician as well as Ludwig Wittgenstein is German mathematician. So both of these are really into the logic, mathematical logic. So these logical operators are of course used in electronic circuit board as well. So you might have seen XOR gate or NOR gate, NAND gate, all these electronic digital circuitry works on the Boolean logic. So without Boolean logic, of course, you won't be able to see these MOOC videos as well. I won't be able to record these MOOC videos as well, or to use a small smartphone. Of course, all this logic is extremely important. Logical operators are also used in a number of applications. For example, MS Excel or Google or Scopus or ISI. Web of knowledge or web of science search, you can use these or not operators. One simple example would be antivirus. So I don't want to say about the biological virus, not biological virus, so I can put that way. Or if I want to say antivirus vaccine, not computer virus. So that kind of logic you can use it. So what is the first rule? The addition rule of the probability. The rule of addition states that the probability that in event A or event B occurs is equal to the probability that event A occurs plus event B occurs minus the probability that event A and B, that is the intersection, occurs. So probability of A union B, so here the symbol is U, union, is equal to the probability of event A plus probability of event B minus probability of event A, intersection B. So that is the thing. So that is basically and. So and symbol is the inverted U. So it is something like small n, right? So that is what the and is. So probability of event A and B occurs. So that intersection has to be subtracted. Otherwise that area will be counted 2 times. So that is the reason why it is being subtracted. Let us see one example. A card is drawn randomly from a deck of ordinary playing cards. You win the game if the card is a spade or an ace. So what is the probability that you will win the game? So the question here is that to get the spade or ace. So this is the question. As you see, the or is always, you can put a plus here. So that means that spade, probability of getting a spade plus probability of getting an ace. You know, that is what. And minus, you will have to actually see that the minus. So we will actually see that what is actually the probability. So that is nothing but probability of A union B, that is equal to probability of A plus probability of B minus probability of A and B. So that is what probability of A is the spade, probability of B is probability of the ace, probability of A and B is spade of ace, ace of spade, that's one card. So we can also say this one in a Venn diagram for easy comprehension. So let me put a Venn here. So this is the probability of spade, while this is the probability of ace. You know, so basically this ace is very less than the spade, because the ace cards are only 4 cards, so it is quite low. You can write that way as well. So spade, the probability is basically there are 9 cards of the spade, there are 9, while ace there are 4 cards of the ace, and now here this you know, this intersection region is actually number 1. So this card is basically ace of spade, there is one card here. So that is why this intersection has to be removed from the total. 9 plus 4 is incorrect, so minus 1, because this area will be doubled. So that is why you are subtracting with 1. So that is equal to probability of A is basically 9. So 9 card out of 52. So this is the probability here. This is only numbers, you know, number 9 cards are there, 4 cards and 1 card. So to calculate the probability is basically S by N. 9 by 52 plus 4 by 52. This is ace, that is probability of B, minus probability of A and B is right here 1. So that is basically nothing but 1 divided by 52. So that is equal to 12. So 9 plus 4 plus 1, because denominator is all same, 12 divided by 52. So that is equal to 0.23. So 0.23 is you know, quite low probability. As you can see, it's only 23% chance. Let us consider another example. So this example is that you flip a coin. What is the probability that you get a head or tail? So this probability is that, you know, to get head or tail. So as you can see, this example is the head. To get the head, the probability, as we know, it is 0.5, because otherwise it is 1 divided by 2 is 0.5. To get the tail is again 0.5, because this is 1 divided by 2. So this one, to get a head or tail, the probability is that, you know, as we see that this coin toss is an example of an independent event. So there is no dependency here. This is an independent, because the first is a head, second is a tail. So the first you are getting a head or tail has no implication on the second to get tail or head. So that is why these are an independent event. So in this case, to get head or tail in the first case, is the probability is that if you toss once, you know, you are getting either head or tail. So the formula is actually very simple, just like the previous one. Probability of A plus probability of B minus probability of A and B. So in this case, that is basically that is the probability of A union B is equal to probability of A plus probability of B minus probability of A and B. So here probability of A is equal to 0.5, that is 1 by 2, plus 0.5 minus A and B. As you see, this is an independent set, there is no probability of A and B, that is basically 0. So that is equal to 1. So naturally, if you toss it, you will get either head or tail. You know, if a baby is born, is it either girl or a boy? So that is also the probability is just 100% or 1 is the probability in this case. Another problem, you roll 2 dice. What is the probability that the sum is 3 or 4? Whiteboard number 8. So in this case, you know, we are having 2 rolls. The first roll you are getting sum is 2 and second roll you are getting sum is 3. So we have to see that the probability of A and B, so A union B. So probability of A union B, that is a addition rule. So probability of A union B is equal to probability of A plus probability of B minus probability of A and B. So in this case, what is the probability of A? A is that the sum is 3, while probability B is sum is 4. So it's not 2 but it's 3 and 4. So these two are the sum, right? Not 2. So it is basically 3 or 4. So this is what you are getting. So how many ways probability of to get 3 in 2 dice? So the way to get 3 is, I can write it here. So to get this 3, it is basically 2, 1, 2 plus 1 is 3, or the first dice is 1, second is 2, right? So the 2 ways to get number 3. Now the sum is, you know, the sum is 4. So to get this number 4, how many ways is it possible? There are 3 ways it's possible. So the first is 3 and 1, second is 1 and 3, third is 2 and 2. So there are 3 ways this will happen to get number 4. This is only 2 ways it will happen, right? So the probability of success is basically A is 2, because to get 3 there are only 2 ways it's possible. So it's 2 divided by, totally there are 36 ways. How did I get this 36? The first throw is you will get 6 ways, and the next throw you are going to get 6 ways, right? Because there are 6 phases of the dice, so you are going to get 36. So n is 36, s, so s by n. Success is 2, this is 36. So that way you are going to get 2 divided by 36 now, plus how many ways P, probability of B can happen? The B means to get 4. There are 3 ways. So you have to put 3 divided by 36. So subtracted with probability of A and B. So there is no way to get 2 and 3. So there is absolutely nothing. There is no way, because this is an independent set. So in this case, the total probability is 2 plus 3 is basically 5 divided by 36 is equal to 0.139. So this is the probability of getting the sum of 3 or 4 in 2 subsequent dice throw. As one can see that the probability is quite low, because it's only 13.9% chance. Next example. In a lottery, you have 1/10th chance of winning Rs20, 1 in 100th chance of winning Rs50, and 1 in 10,000th chance of winning Rs1000. Now lottery costs 3 rupees. Should you buy? Is it worth buying? So is the risk worth taking? So in this case, the mathematical expectation is basically A1 multiplied by P1 plus A2 multiplied by P2 and so on. So basically what it means is that there is 1/10th chance to get 20 rupees, right? So 1 by 10 is a probability you are multiplying with the amount, the probability. So it's A1 into P1 or P1 into A1. So it's the probability first here, probability multiplied with the rupees 20, right? So there is 1/10th chance of getting 20 rupees plus there is 1 in 100 chance of getting 50 rupees in the lottery. So 50, this has to be multiplied, plus there is 1 in 100 1 in 10,000 chance to get 1,000 rupees. So this is what the expectation is all about. So you're just multiplying the amount with the probabilities and you're just adding upon each other. So that is equal to this you can simply sum, you can solve it as 2 plus. So this it will go 5 into 10, so it's basically 0.5 plus. So this is nothing but 0.1. So that is equal to basically 2.6. So if the expected value is 2 rupees 60 pice. So if the lottery is costing 3 rupees, then of course 3 is higher than 2.6, so it is not wise. If the lottery is costing less than 2.6, so if it is only 2 rupees 50 pice, yes, then you may consider the risk is worth taking. So that is what the mathematical expectation is all about. So as we have just seen, this question is something to do with mathematical expectation. So what is mathematical expectation or ME? If the probabilities of obtaining the amounts A1, A2, A3 all the way to AK are P1, P2, P3 all the way to PK, then mathematical expectation E is equal to A1 multiplied with P1 plus A2 multiplied with P2. So you are just multiplying the probability with the amount. So you sum it all the way to the last number. So that is what you call the mathematical expectation. So ME is usually, it is basically the value. You are going to get a value like rupees or the dollars. So ME, that is mathematical expectation, informs us whether the risk is worth taking or not. So it is very handy for the real life situations. You can actually see that really worth the risk is worth taking, especially if you are investing in a mutual fund, for example. You can this trick can come handy. So if you roll a die, you get 1. If you get 2, then you are going to get rupees 2. And if the dice is 3, you are going to get rupees 3, like that all the way to 6. Okay. So to play this game, you have to invest 3 rupees. So is the 3 rupee the risk is worth taking or not? Let us solve this problem in whiteboard. So in this case, if you get 1, you are going to get RS1. If you get 2, you will get rupees 2 in the dice. 3, you are going to get rupees 3. So and so on. So if you are getting 6, you will get rupees 6. So in this case, how do you calculate? So each one, to get 1 in the dice, what is the probability multiplied with this one? So that is what you are going to get. So each of these probability is basically nothing but 0.17. That we have already calculated, this 0.17. How did we calculate? So there is only one way out of 6. So 1 by 6 is 0.17. So that is the probability of each of these event. So let us calculate the first one. 0.17 plus. So 0.17 multiplied by 1. So that is the first the one, because you are getting 1 rupee for if you are getting 1. 0.17 multiplied by 1 plus. Next, 0.17 is the probability multiplied with number 2. 2 is the rupees, plus 0.17 multiplied with 3 plus 0.17 multiplied by 4 plus 0.17 multiplied with 5 plus 0.17 multiplied with 6. So this is how to calculate the expectation. So if you do this calculation, you are going to get the answer 3.5. So 3.5 is the expected value, 3.5 rupee or 3 rupee 50 pice. So if the throw or the game costs 3 rupees, then is it worth taking or not? Yes, because that value of 3 rupees is less than 3.5. So it is worth taking. So if the throw cost 4 rupees, Is it worth taking? It's not, because the expected value or mathematical expectation is only 3.5. So if you're paying more than that, it is not, the risk is not worth taking. So in summary, the probability that event A or event B occurs is equal to the probability that event A occurs plus the probability that event B occurs minus the probability that both the events A and B occurs. So A and B is basically, you have to multiply these two probabilities. Mathematical expectation is the product of the probability of an event occurring denoted with Px and the value corresponding with the actual observed occurrence of the event. It informs us whether the risk is worth taking or not. Thank you for watching.